Cool. All right, you ready to do this?
I'm ready, yep.
All right, what are we doing? Chapter 5, water.
Water.
Good one. It's a good one. Water is really important for the embalming process. Water is going to be in every embalming solution. It's in a bottle of embalming fluid. Even if there's waterless embalming, if that's the thing people do, waterless embalming, for whatever reason, there's still water throughout the embalming process. There's water in the body.
Yeah. Well, it makes
what percentage of a human is water?
About 70%, 65%.
65 to 70%.
Life is based on water. It's the most important compound on Earth, really.
Yeah, it is. And there's some unique properties of water, right?
Yeah, it's for a very small molecule. It has a high boiling point and a high freezing point, and it's all because of hydrogen bonding.
Yeah. Well, and I noticed you're drinking coffee, but what happens if you're drinking water with ice in it? Like, solid water floats.
Right. That's also something unique. It is about water is that the solid form of it is less dense than the liquid form, which is very unique.
It's found all over. It's got these unique properties, and so it's got this polarity. You mentioned, what is polarity? Because that's what makes this all happen, right?
It is, and in simple terms, it just means one part of the molecule is positive and one part of the molecule is negative.
Okay.
And they attract each
other. A
other.
lot of people that are watching this are visual learners. Can you draw out what that means?
Yeah, sure.
Get us a pen. All right, so you're drawing a water molecule.
Correct.
Keep talking. Okay, you're drawing a water, so you've got two hydrogens. H2O is water. Okay, so what is polarity in this molecule? What does that look like?
In simple terms, the oxygen is negatively charged and the hydrogen is positively charged.
It's got a positive charge. Okay, cool.
So that's a polar molecule. But
so there's an imbalance of charges.
There's an imbalance of charges.
Polarized.
That's very good. That's a good way to say it.
You're good. That's
now
good.
Just imagine,
that's okay.
That works for me. Now just imagine if there's another water molecule around. And we're going to draw it this way.
This way.
This way.
He's drawing it this way.
See, this is negatively charged.
And that's positive. Again, the hydrogens are positive. Now they would repel each other, though, right?
Those
would
repel. But there's an attraction right between those two.
What do you call that?
That's hydrogen bond. That is hydrogen bond.
That's a hydrogen bond. Different from covalent.
It's different from covalent because it's not an actual bond. It's really an attraction.
But it's also
the vernacular
different from
is
an ionic bond.
Yeah.
Okay.
The vernacular is that it's a bond, though. And
but yes.
So what's happening in simple terms is that the water molecules in the ocean, in the body, in the glass of water, in your coffee are all holding each other. Think of water molecules as holding hands with each other.
Yeah.
And
boiling breaks it apart.
And boiling breaks it apart. But it takes a lot of energy to break that handhold.
Okay, so now here's the question. I started off by saying there's a lot of water in the embalming process. I think everybody would agree with that.
Yeah.
Now, how does this affect embalming? Well, I'll tell you, Robert,
okay,
since you asked.
I know.
Here's the thing. Water tends to stick to itself. It tends to stick to surface. What's a meniscus when you're looking through a test tube?
So a meniscus is if you have water in a test tube, put this in your mind's eye, there's a little curvature in it.
Yeah.
And what's happening is that's an example of the hand holding I was talking about. The water in the middle is pulling down the molecules above it, and on the edges, that's not so dramatic. So that's why you get a meniscus.
Right. Now, if you imagine a test tube as a capillary, and the human body, like Robert's body, has roughly 60,000 miles of capillaries, and I don't know who measured that, but it's a big distance.
Someone with a lot of time on their hand.
They're narrow, and water doesn't move really well through that vasculature, that capillary. So we add in chemicals that we'll talk about, it's talked about in the textbook, called surfactants. That helps disrupt those chemical bonds. You know, an example of a surfactant is soap. It makes water wetter. What are other things people say about surfactants?
Well, ultimately what surfactants do is they interfere with that hydrogen.
Well, we can erase it, right? Rather than drawing more, they do this essentially. They kind of go doo, doo, doo,
okay,
doo.
If that works for you, that's what they do. They eliminate the surface tension, and you wouldn't have that curvature, that meniscus anymore when you have surfactants.
Cool. Very cool. Mm-hmm. The last part of the chapter talks about solutions. Now, there's some key definitions which we won't really cover. Solute.
Well, in the solution, you have a solute, a solvent, and a solution. So
yeah, and it's kind of tough because they all sound the same.
They
so
do
you have to spend some time with it.
Make sure you don't get those confused. They're important.
And the other two that really can be confusing are hypertonic and hypotonic.
I get those mixed up either.
Yeah, I'll say it again, hypertonic and hypotonic. So that's when you compare two solutions. Mm-hmm. and to a relative solution. A hypertonic solution has more solutes in it, and a hypotonic solution has less solutes in it.
So just to be clear, a solute is what gets dissolved, a solvent is what does the dissolving, and the solution is what you call what is created.
Yeah, yeah. And those concepts are really important when you talk about moisture content of a body that you're embalming. So if a body has too much moisture and it's edematous, you want to draw the moisture out, so you use a hypertonic solution, right? Too much salt essentially dries the body out. If the body is too dry, you want to use a hypotonic solution. That adds moisture to the body.
Yeah.
Yeah? Cool. Are we good with water?
I think we did
I think
water.
so.
I think we did it. Yep.
I think we're good. All right.